Assalamualaikum and hi to both panel and my fellow friends. My name is Farihatul Huda binti Hamid and I'm from AS257. Today, I will be presenting my final year project review titled Challenge of Incorporating Azolla in Broiler Diets, Impacts on Nutrient Absorption and its Physiological Pathway. Azolla is an aquatic fern that is rich in protein, vitamins, and mineral. It has gained attention as a low-cost, sustainable poultry feed alternative to conventional soybean or corn-based diets. However, its use presents challenge due to its high fiber, low energy, and the presence of anti-nutritional factors or ANF. Therefore, this review focuses on how Azolla affects nutrient absorption, digestibility, metabolism, immunity, and the gut microbiota in broilers. The main problem is that Azolla's fiber and ANF limits digestibility and nutrient absorption. This can interfere with the important physiological process like glycolysis, protein synthesis, and immune function. So, I structured this review to answer 5 key research questions related to digestion, ANF mitigation, metabolic pathway, immune response, and gut microbiota. The objective of this review were to evaluate Azolla's impact on broiler digestion, metabolism, immunity, and gut health, and also to explore how anti-nutritional factors can be mitigated. The significance of these studies lies in its potential to reduce feed costs, improve poultry health, and support more sustainable farming practice by reducing reliance on imported feed ingredients. Next, we are going to the literature review. So, Azolla contains 25 to 35% protein, essential amino acids, vitamin A and B12, and minerals like iron, calcium, and magnesium. It grows rapidly and forms a nitrogen-fixing symbiosis with cyanobacteria. However, Azolla has low metabolizable energy and high fiber, making it less digestible than the conventional feed. The table in this slide compares Azolla's nutrient composition with other common feed ingredients. For the broiler part, let me begin with the digestive system of the broiler chicken. Feed passes through the crop, then into the ventriculus for the enzymatic digestion, followed by the gizzard for physical breakdown. It then moves into the jejunum and ileum, where the nutrients are absorbed through the villi. However, broilers have a limited ability to digest fiber, making Azolla's high fiber content a challenge. Undigested fiber can interfere with the enzyme and reduce nutrient uptake. Now, let's moving on to the immune system. Around 70% of broiler immunity originates from the gut, particularly the gut-associated lymphoid tissue, GALT, which includes the spleen, thymus, and bursa of Fabricius. This connection between digestion and immunity is important when evaluating feed ingredients like Azolla. Azolla contributes positively to the energy metabolism of broilers, especially in the glycolysis and TCA cycle pathway. In glycolysis, it provides glucose along with the cofactors like B vitamins, iron, and zinc, which help activate enzymes like hexokinase and PFK1, leading to increased ATP production. In the TCA cycle, Azolla contributes amino acids that convert to acetyl-CoA and minerals like magnesium that support mitochondrial enzymes such as succinate dehydrogenase. This improves energy efficiency during broiler growth. Azolla is also rich in amino acids like leucine and lysine, which activate the mTOR pathway, a key regulator of a muscle protein synthesis. However, its benefits may be limited by anti-nutritional factors such as phytates, tannins, and saponins, which can block enzymes and reduce nutrient bioavailability. So let's moving on to the research question. So moderate Azolla inclusion between 5 to 15% will improve protein digestibility, feed conversion ratio, and growth performance. It enhances gut morphology by increasing villus height and reducing creep depth, especially in the jejunum and ileum. For example, according to the Salman and Roy et al., broilers fed 10% Azolla showed up to 20% increase in a villus height and lower FCR. Several studies also reported the inclusion level above 15 lead to reduced absorption due to the fiber and ANF. Processing Azolla using fermentation, pelleting, or enzymes like phytase can help improve nutrient bioavailability. For the research question 2, Azolla contains ANF like phytates and tannins which reduce nutrient absorption. Among the techniques tested, fermentation is the most effective. It breaks down ANF, increases protein digestibility, and enhance mineral availability according to the Gupta et al. And several studies. So other methods like soaking, germination, and heat treatment also help but are less efficient according to the Samtia. So the best option to improve Azolla's nutritional quality is fermentation, especially before feed formulation. To answer the research question 3, I reviewed the azolla influenced the metabolic pathway of the broilers. Most studies agree that azolla enhance energy production and protein synthesis, especially at 5 to 10% inclusion. If we look at the bar graph on the left, we can see that the 5 to 10% azolla inclusion, there is a noticeable increase in glycolysis enzyme activity, mitochondrial efficiency, and protein synthesis. It improved enzyme activity and mitochondrial function while promoting muscle growth via mTOR. So however, some studies showed reduced effectiveness when azolla was included at more than 15% due to its high fiber and ANF. So in conclusion, azolla supports metabolic pathway only when used the right dose and with the proper processing. For research question 4, azolla also support the immune system, a key part of the physiological pathway mentioned in my title. So azolla-fed broilers showed high lymphocyte and granulocyte counts and a lower heterophil lymphocyte ratio, which indicates better stress response according to the Chili et al. It also improved the size of immune organ like the spleen, thymus, and bursa of Fabricius, according to the Mehras. On a molecular level, azolla increased expression of cytokines like IL-6, IL-10, and TLR2, especially at a 5 to 10% inclusion level of azolla. So for the last research question, azolla affects the gut microbiota, which also plays a key role in nutrient absorption and immunity. It promotes beneficial microbes like Lactobacillus, Bifidobacterium, and Bacillus subtilis, while suppressing harmful bacteria such as E. coli and Clostridium, according to the Sama et al. This change improved mucin secretion, virus health, and the production of short-chain fatty acid like propionate, which support gut function and reduce inflammation. This shows that azolla influenced the microbial ecosystem, not just direct digestion, according to the several studies that I have reviewed. In conclusion, azolla is a promising feed additive for broilers, especially at 5 to 10% inclusion. It improves digestibility, support metabolic and immune function, and also enhance gut health. But at a high level, fiber and ANF can reduce its effectiveness. My review confirms that azolla impacts not just nutrient absorption, but also physiological pathway which align with my project title. However, there are still research gaps to be addressed. First, there's limited data on nutrient transporter genes like SGLT1 and PEPT1. These are key for nutrient absorption, but most studies don't examine how azolla affects them at the molecular level. Second, cytokine profiling is still incomplete. Only a few markers like IL-6 or IL-10 are tested, while the full immune response remains unclear. Third, most studies are culture-based microbiota methods, which miss a large part of the gut microbial community. We need DNA-based technique like 16S RNA sequencing for the deeper insight. And fourth, there's no standardized optimal inclusion level. Studies vary too much in dose feed base and processing, so the dose-response trials are needed. These gaps show that while azolla is promising, we still need more detailed research to unlock its full potential. So this is the reference that I used to finish my critical review for the final year project. That's all from me. Thank you.